Hey everybody, we're live and in stereo. So now we're gonna attempt another past paper, which is 0620/21 May June 2022. And welcome back to a 3 a.m. past paper session with Suleiman, right? So let me just write my name down. Obviously, my name is Suleiman and Khan, like the British says. Yeah, Khan. So let's start off with the past paper. Question number one says, which two gases will diffuse at the same rate? Now, the rate of diffusion actually depends on the MR and it depends on the temperature. And it's saying it has the same temperature. So if this temperature is constant, the only thing that'll determine the rate of diffusion is the MR. And since the rate of diffusion is going to be the same, you'll realize that the MR should actually be the same. So now let's check the MR. Carbon monoxide and carbon dioxide. Obviously, they will have different MRs because this has one more oxygen than this. That's just from logic, dudes. But even if you wanted to check it out, carbon is 12, oxygen is 16. That's gonna give you a total of 28 AMU. Carbon is 12, oxygen is 16, and you have two of oxygen, so you times it by 2, add these two together, that'll give you 44, right? So 28 is different than 44. Carbon dioxide has a greater MR, therefore it'll diffuse slower than carbon monoxide. And they want you guys to find out whether these two gases will diffuse at the same rate. So which two gases will diffuse at the same rate? Now if you check carbon monoxide and nitrogen out, I can literally say that this is my answer. Why? I can reckon because carbon is 12, oxygen is 16, you add these two together gives you 28. One nitrogen is 14, and since you have two of those, 14 times 2 is also 28. So 28 AMU, 28 AMU, since they have the same MR at the same temperature, they will diffuse at the same rate. Therefore B is the right option. A student measures the time taken for 2 grams. So if he wants to measure the time taken, he needs a stop clock. How do I know it's talking about apparatus? Because I just peeked here. For 2 grams of magnesium, so 2 grams of magnesium, so he needs a balance to measure this 2 gram of magnesium, and he needs to measure this he needs an apparatus to measure this 50 centimeter cube of dilute sulfuric acid. And that apparatus right here is given. It's the measuring cylinder, right? So you realize you need a stop clock, balance, and a measuring cylinder. Stop clock, balance, and a measuring cylinder. 1, 2, and 4 is the answer. And if you guys might ask yourself, why is 3 wrong, right? First of all, it's not mentioned, but 3 is wrong because there's no mention of a temperature change. A thermometer is only used if you were to measure the temperature change or something to do with the temperature. So you don't want to do that. That's why 3 is the wrong option. The number of protons and neutrons and electronic structure of 4 particles X, Y, and Z are shown. Which particles will have the same chemical properties? Again, chemical properties depend on the number of electrons, and specifically we talk about the elements, right? So the number of electron of elements. So if you have 2 elements and they have the same number of electrons, you'll realize that they'll have the same chemical properties. Now if you check this out, if you check the electronic structure basically tells you the number of electrons. And which number of electrons are we specifically talking about? We're talking about the outermost electrons, right? So the number of outer electrons. So if you check it out, this has 8 outer, so 2 8 means it has 2 shells. First shell it had 2 electrons, the second shell it had 8 electrons, so it has 8 electrons in its outermost shell. This has 8 electrons in its outermost shell. This has 6 electrons, this has 6 electrons. Now the answer could either be WZ or the answer could be XY. So now let's check out W and Z or X and Y. Let's check out which one is going to be correct. If we check the number of protons out, W and Z, W has 8 protons and Z has 10 protons, right? You realize because W has 8 protons and it has the electronic structure of 2 8. How is this possible? Number of protons is 8, but it has an electronic structure of 2 8, which means that protons are 8 but electrons are 10. That is only possible if it had gained 2 electrons, right? So it's no longer an element, it's an ion. Therefore we will cancel out W. W is out of the way. So if W is cancelled out, X and Y are the only remaining option with us, and we can literally just circle C, everybody. Okay, the reason why I cancelled out W, let me explain it again, is because it's not an element. If we talk about same chemical properties, we talk about the number of electrons in the outermost shell of elements. If they are same, your chemical properties will be the same. But since W is not an element, it's an ion, it's a charged particle. Why? Because it had 8 protons but 10 electrons, which means that for a neutral atom it should have had, if it was neutral, if it had no charge, if it was in its elemental state, it would have 8 protons and 8 electrons, but it has 10, which means that 2 were gained. So it's an ion. We're not talking about elements when we're not talking about ions when we're talking about chemical properties. Okay. Which substance would be pure for the intended use? A drug for curing disease. Obviously, this will be pure. If you don't use a pure drug for curing disease, it's literally a general question. If you don't use a pure drug for curing disease, you're gonna kill a patient, right? So A is the right option. Don't even have to look at the others. Metals and ionic compounds have similarities and differences in their structure and properties. Which row about metals and ionic compounds is correct? Both contain positive ions. That's true. So C and D is wrong. Let's check between A and B. Why do both contain positive ions? Because if you check your ionic compound, let's say NaCl, Na has a charge of 1 plus, Cl has a charge of 1 minus. So that's a positive ion right here. And in metals, you have a lattice of positive ions in its C of delocalized electrons. So that's a positive ion right here. So yeah. And if you check it out, the difference is only ionic compounds contain anions. Yep, only ionic compounds do contain anions. So I'll say A is my answer. Anions mean negatively charged ions. Negatively charged ions are known as anions, right? And if you check it out, the metals, they don't have any anions, they have just delocalized electrons. And if you check even B out, it says ionic compounds conduct using a sea of electrons. No, they conduct because of free moving electrons only in molten and aqueous state. So B is also wrong. Which diagram represents the outer shell electron arrangement of a nitrogen molecule? So nitrogen is in group 5, therefore it needs 3 electrons to become stable, therefore it makes 3 bonds with the other nitrogen, right? And one bond literally means a pair of electron, being shared, a pair of electron being shared, a pair of electron being shared. So if I were to draw this nitrogen, there are literally 3 pairs of electron shared. So 1, 2, 3, right? And nitrogen, since it's in group 5, this nitrogen will share 1, 2, 3. This nitrogen will share 1, 2, 3. So since it's in group 5, it's sharing 3. 2 will be left here, 2 will be left here, right? And if you check your option, D is the right option. Here they've added crosses on the left, I did it on the right. Doesn't make a difference. The sharing is the same, right? So D is the right option. The equation for the reaction between barium chloride and dilute sulfuric acid is shown. Okay, and now it says which row shows the state symbol for the equation. Barium chloride is obviously going to be aqueous. It's soluble in water. So sulfuric acid, since it's an acid, it's also going to be aqueous. So B and C and oh my god, you literally got your answer. A is the right option. How did you get it? See, liquid is not possible, so B and D is wrong, and this liquid is not possible, so this is also wrong. A is the right option. How quickly did we get it, right? But even if you check barium sulfate out, barium sulfate is an insoluble salt. If you remember LMS Castroba, right? All sulfates, NACSAC we learned that all sulfate were soluble except for LMS, lead, mercury, silver, and Castrobal, calcium, barium, and calcium, strontium, and barium. So you realize that barium sulfate is insoluble, therefore it'll be solid state, and HCl is again aqueous, right? Solid aqueous is the right option. The relative atomic mass AR of an element is determined by comparing the mass of one atom of an element with the mass of one atom of element Q, which is carbon. That was what the AR was. That's what the scientists did in order to get whole numbers in the periodic table, right? The equation for the reaction between aqueous lead nitrate and aqueous sodium chloride is shown. If 100 centimeter cube of aqueous lead nitrate has a concentration of this much reacted with excess sodium chloride, which mass of lead chloride is obtained? Okay, again, it's a simple moles question, simple stoichiometry. You had 100 centimeter cube of lead nitrate, so PbNO3, and that's what? 2 twice, right? And you don't need centimeter cube, so you need to cancel it out, and 1 decimeter cube, it has 1,000 centimeter cube. And then you don't need decimeter cube, you need moles in order to use this relationship between lead nitrate and lead chloride. So from here, 1 decimeter cube has how many moles? 0.1, right? 0.1 moles. It's given in the question. And then you know you don't need moles of lead nitrate, you need moles of lead chloride. So you know okay, 1 mole of lead nitrate will give you 1 mole of lead chloride. And then you literally can find out the mass. Okay, 1 mole of lead chloride will give you how much mass? What is lead? If we check it out, lead is right here. That's 207, right? So 207 plus 71, because 1 chlorine is 35.5. So you could literally find this out. If I do this calculation, 100 times 0.1 times 207 plus 71, that's gonna give me, what's that gonna give me? 2780 divided by 8000. So the answer is 2.78, guys. So the answer is 2.78 grams. And do we have the option? Right here. C is the right option. If you don't know what I've done here, you could watch my moles and stoichiometry questions. That'll make moles a hella easy for you guys. Okay, you don't need any formulas. The diagram shows the electrolysis of concentrated hydrochloric acid and concentrated aqueous sodium chloride, at which electrodes is hydrogen produced. So in concentrated hydrochloric acid, you have the H plus ion, the OH minus ion, and the from the water. And since it's hydrochloric, you'll also have the chloride ion. So again, at the electrode number 2, because this is the cathode, it's negatively charged, it'll attract this H plus towards itself. 2 H pluses will go together, gain 2 electrons, and become hydrogen. So obviously hydrogen is produced at electrode 2 right here. And if you check the next apparatus out, here you have concentrated aqueous sodium chloride, which means you have Na plus Cl minus, that's sodium chloride. And since it's concentrated aqueous, you mean you have H plus and the OH minus 2. Now between Na plus and H plus, which one will discharge at electrode 4? There's a race between the two, and we realize since sodium is more reactive than hydrogen, the hydrogen ion will be more reactive than sodium. And we did a lot of detail why this was the case, but the hydrogen ion will win the race and it'll discharge at electrode 4. So it'll go, 2 hydrogens go together, hydrogen ions, they gain 2 electrons and become H2. So electrode at electrode 2 and electrode 4, therefore D is the right option. Aqueous copper sulfate is electrolyzed using copper electrodes. Just make out your copper electrodes, make out this electrolysis chamber, copper 2 sulfate, copper 2 plus, sulfate 2 minus. Since it's aqueous, you'll also have H plus and OH minus. Yeah. Now it says, what is the ionic half equation at the cathode? So at the negative electrode, which one will discharge? You have a competition between Cu2 plus and H plus, and since since hydrogen is more reactive than copper, the copper ion will be more reactive than hydrogen. So this is gonna win the race. Copper 2 plus will go and discharge at the cathode, and what it'll do is the cathode is negatively charged, so it'll be like, hey, make me neutral. So copper 2 plus will go together to get 2 electrons, gain these 2 electrons and get copper solid, right? Be reduced to copper solid. So copper 2 plus gains 2 electrons and becomes copper solid, right? Which row and why is like A wrong? Because A is basically the opposite thing. It's saying a copper solid is becoming the copper 2 plus ion and is giving 2 electrons, which is not the case. Which row identifies a chemical change and a physical change? Boiling is a chemical change, but burning is also a chemical change. Physical change literally means a change in appearance, right? Or a change in state. That's what we studied. And chemical change meant new products were being formed, or maybe a chemical composition was changing, and all of that good stuff, right? So physical change is just the change in appearance state. No chemical composition is changing whatsoever. In chemical change, you'll also have new products. Physical change, no new products. So if you check it out, if you boil ethanol, that's not a chemical change. What am I saying? Boil ethanol is a physical change. Why? Because you had ethanol which was liquid. What did I do, man? I don't know. It's that time of the year for me. So ethanol was liquid. You boil it out, it's still ethanol. No change in its chemical composition. Now it's gas, right? So boiling is not a chemical change. It's a physical change, right? They've written this opposite. Now burning ethanol is absolutely a chemical change, because burning is combustion, right? So ethanol is a fuel. You burn it with oxygen to get carbon dioxide and water. Since new products are being formed, you think it's a chemical change. Now physical change, evaporating ethanol, yes, that is a physical change, because ethanol is a liquid, you're converting into a gas, so it's no change in its chemical composition. The only thing that changed was its state, right? Its appearance. And now C part says dissolving ethanol in water. Again, dissolving it only changes its appearance. It's the same ethanol. Burning ethanol, again, that's not a physical change, that's a chemical change. So C is also wrong. D, evaporating ethanol, again, that's a chemical change. Nahi hai ye, that's a physical change. Okay. So we know all of this good stuff. B was the right option. The equation for the reaction between gaseous hydrogen and gaseous iodine to form gaseous hydrogen as stated. The reaction is exothermic. Which statement explains why the reaction is exothermic? So the reason why the reaction will be exothermic is the overall energy that was taken in during bond breaking is gonna be less than the overall energy that is released during bond formation or given out during bond formation. So energy that is taken in during bond breaking should be less than the energy that is given out during bond formation. So if you check it out, energy is released when H and I bonds are broken. No, it's taken in. The bond energies of the reactants are larger than the bond energy of the products. No, then that would make it endothermic. The products are at a higher energy level than the reactants. No, in exothermic, if you check it out, in exothermic, the reactants are right here, the products are right here. Reactants have greater energy than products. More energy is released when two HI bonds are formed than it is used when H and I bonds are broken. Yep, that's it. More energy is released. They just change, they just rephrase it. They're saying more energy is given out when HI bonds are formed than it is taken in when H and I bonds are broken. So that's 2. Acidified aqueous silver nitrate is added to a test tube containing aqueous chloride ions. So if you had silver nitrate, Ag plus NO3 minus, and you had like silver ion somewhere, you realize that when Ag plus and this silver ion, they'll come into contact with each other, they'll form AgCl, which is an insoluble salt, right? Because you learned about group 7. Remember when we studied solubilities, we studied that all group 7s are soluble except for LMS, lead, mercury, and silver, right? So AgCl is gonna be a insoluble salt, and we realize that silver chloride is white, silver bromide is cream, and silver iodide is yellow. So it's gonna be a white precipitate. So between C and D, let's check it out. Now it says precipitate dissolves if you leave it in sunlight. No, it's an insoluble salt. Why in the world would it dissolve then, right? So C is also wrong. Therefore, my bad. C is also wrong. Therefore, you can literally say D is the right option. But even if you check the explanation for D and all of that stuff, the precipitate turns gray, so it might turn gray after you leave it in the sunlight, right? Why? Because silver ions are reduced, and they are reduced. If you check it out, you had Ag plus and Cl minus, and now it's becoming AgCl. So you realize that silver ions jo the, they were actually, what were the silver ions doing? The silver ions were gaining an electron to become Ag, right? So that's what's happening. That's why the precipitates are turning gray. My bad. That's why it's turning gray, and that's why this insoluble salt was being formed, because these two reacted. So the sun literally reduces it. This you could have done by the elimination method, because you know the precipitate won't dissolve, right? Water is added to anhydrous copper sulfate. Anhydrous means it has no water molecules. It's just simple copper sulfate, and we know that anhydrous copper sulfate is white, right? And when water is added to it, it forms a salt, but it also has these 5 water molecules attached to it, which we call water of crystallization. And this was a test for water, because anhydrous copper sulfate is white, and copper sulfate, which has the water molecules attached to it, it becomes blue, right? So the copper sulfate will turn blue, therefore C and D is wrong. And the solution will get colder or hotter. So the reason why it would get colder is if it were an endothermic reaction. The reason why it would get hotter is if it were an exothermic reaction. Now check it out, think about it, whether we've studied this is an exothermic reaction, but think about it just for a second. Let's see we didn't know if it was an exothermic reaction, right? So if you check it out, you'll get copper sulfate dot 5H2O, right? Now check it out. Copper sulfate, no bonds of copper sulfate are being broken, because on the left hand side and the right hand side is this exact same. No bonds are being broken. No bonds of H2O are being broken. It's the same on the left and right hand side. The only thing that is changing is that new bonds are being formed between copper sulfate and this water molecules, because this entire water molecule is being added to it, right? So if bond formation is the only thing that is taking place, you'll realize that bond formation is exothermic. Therefore you would say the solution is getting hotter. So one way to deduce that 2, right? Aqueous iron 3 chloride reacts with aqueous potassium iodide. Which statement is correct? In the balance equation, V, W, X, and Y have the same value. Yep, they'll have the same value because iron and iron are balanced, chlorines and chlorines are balanced, the K and the K is balanced. The only thing that's not balanced is the I right here and the I2 right here, right? So you can say, oh, if we add 2 here, then it wouldn't be. No. If here you have one I, here you have two I's, you could just balance out this thing. Okay, what do I multiply this 2 with to get 1? So X equals 1 over 2. So if you just add a 1 over 2 right here, you will get a balanced equation. And then even if you said, okay, no, I want a whole number, you multiply this entire equation with 2, you'll still have the balanced equation. So V, W, X, and Y will remain the same. So that is true. Potassium iodide is an oxidizing agent. Let's check it out. Potassium iodide is not an oxidizing. We know it's a reducing agent, but let's check it out. I here is -1. Its oxidation state, and then it goes from -1 to 0. Why? Because the oxidation state of any pure element is going to be 0. Now it's going from -1 to 0, so it's oxidizing itself, and since it's oxidizing itself, it's going to reduce something else. So it's a reducing agent, not an oxidizing agent. So 2 is wrong. So 1 and 3 should literally be your answer, B, without even looking at 3. But let's check it out. A dark brown solution is produced in the reaction. Yep, it is, because potassium iodide, it's going to be it's going to oxidize itself to reduce something else, and when it gets oxidized, the I2 aqueous will be brown, right? That was the observation for Ki. Which statement about acid is correct? A strong acid has a higher pH than a weak acid. No, a strong acid should have a lower pH, like relative to 1, 0 ke kareeb hona chahiye. It should either be like 1, 0, or maybe like 1.2 or something like that. It shouldn't be higher than that, because the higher you go, the weaker the acid becomes. A strong acid is a proton acceptor. No, its acid is a proton donor. A weak acid is a proton donor. Yep, that's true. A weak acid is fully ionized in aqueous solution. No, it's partially ionized, right? So that is also wrong. Now, question 18 says, the oxides of two elements X and Y are separately dissolved in water, and the pH of each solution is tested. So pH of this solution is 1, which means that this is going to be an acidic oxide. And acidic oxide kaun se hote hain? Non-metal oxides are acidic oxides, right? With some exceptions, which we studied. And this will be obviously a basic oxide. That's why it's giving you guys a pH of that of a base 13. Alkali ka pH aa raha hai. And you realize that basic oxides are metal oxides with some exceptions. So let's check it out. Which one is an acidic oxide and which one is a basic oxide? So X is acidic and Y is basic, so C and D is wrong. And the metal oxide will obviously be Y, therefore B is the right option. An acid is neutralized by adding excess of an insoluble base. So you had an acid here, you added excess of insoluble base, so this became, and it says a soluble salt is formed. So this is all a soluble salt now, but since it was an excess of an insoluble base, you realized that a chunk of it would remain because it was an excess. Not what is an excess? Any substance that is the reactants which remain after the reaction is over. So this will remain. So what are you going to do to obtain this pure salt now? And the salt is aqueous. You want pure salt. So what are you going to do? First of all, you're going to filter out this this big fat chunk of the insoluble salt that is remaining. You'll get the salt, aqueous salt, which is going to be your filtrate. And you need pure salt, which means you need it in a solid form. So once you get this aqueous salt, you're going to actually start vaporizing it to the point of crystallization. So first of all, vaporization will take place, or evaporating will take place. So you're going to evaporate it in an evaporating dish or a china dish to take out all the H2O molecules out of it, and you're going to do it till the point of crystallization. Then the crystallization takes place, you're going to stop, and you'll get your pure salt. So first filtration, then evaporation, then crystallization. So D is the right option. The electronic structure of an element is shown 281. And it says which statement about Z is correct. So obviously if the electronic structure is shown, this 281 is literally telling you it's in period 3. It has 3 outermost shells, so it's in period 3. That's true. Is it a metal? This last valence electron, it has 1 valence electron, which means it's talking about it's a group 1 metal, right? So yep, that's also true. It has 2 outermost electrons. It has 2 outer shell electrons. No, it has only 1 outer shell electron. So 1 and 3 is the right option. And even if you wanted to check it out, 281 means it's in period 3. The 281 is telling you it's in 1 shell, 2 shell, 3 shell, and the number shell tells you the period, so it's in period 3. And the outermost shell will tell you the valence electrons, which will tell you the group number. So period 3, group number 1, and you can actually check it out. Period 3, that's period number 1, 2, 3, group 1. They were talking about sodium right here. Okay. Elements in group 4 of the periodic table are shown: carbon, silicon, germanium, tin, lead. What does not occur in group 4 as it descends, right? So carbon, silicon, germanium. So group 4 means saying down the group, what does not occur? The proton number of the elements increases. Obviously, this occurs. Like, check it out. Group 4 is right here. The proton number is increasing. Carbon had 6, silicon has 14, this has 32. So proton number is increasing. So that's wrong. The elements become more metallic. That's also true, because the metallic and non-metallic character depends on the staircase, right? So after the staircase, you'll have metals. The farther they are from the staircase, the more the non-metallic they get, and the backward from they are from this staircase, the more metallic they get. Now realize, okay, check out group 4. This is a non-metal, this is a non-metal, but since this is behind the staircase, this becomes a metal. This is more farther behind the staircase. This is the staircase, it's 2 farther, and then this is the staircase right here, and this is 3 farther. So lead is more metallic than all of these, right? So realize the metallic character actually increases down the group in this. So B is the wrong option. The elements have more electrons in their outermost shell. No, the element has the same number of electrons. That's why they are arranged in the same group, because the reason why the elements were combined in one group is because they had the same number of outer electrons, right? My bad, guys. So C is the right option. The elements have more electron shells. That was true, right? They have the more electron shells. So they were asking about which would not occur. So obviously this would not occur. They don't have more electrons in their outer shell. They have the same electrons in the outer shell, right? Now, element M forms both an M plus and M2 plus ions. Obviously, it's going to be a transition element, because that's the property of transition elements. They have variable oxidation states, guys. In the extraction of aluminum by electrolysis, cryolite is added to bauxite ore. Now, why was cryolite added? Because it is an impurity, and the impurity will lower the melting point of that electrolyte, and you'll realize because of that you will have less cost, right? So it is not a catalyst; it lowers the melting point of electrolyte. And then which row describes the role of cryolite and gives the half equation at the cathode? So what will happen at the cathode? Cathode is the negative electrode. Why? Because panic. Positive is anode, negative is cathode, only for electrolysis, right? So what will happen is the Al3 plus, you'll have the Al3 plus and the O2 minus, you'll have no more ions because it's in its molten state, so the Al3 plus will discharge at the cathode, so Al3 plus will gain 3 electrons to become Al, right? This is wrong because you aren't forming 3 Als. For 3 Als, you needed 3 Al3 pluses to go and gain 9 electrons, right? So C is the right option. Mild steel is galvanized to prevent corrosion of iron. Which statements about galvanizing is correct? So galvanizing is prevents corrosion because the zinc forms an alloy. Oh my god, that's wrong. Zinc does not form an alloy. It's in galvanizing, it prevents corrosion because the more reactive metal is actually is getting sacrificed itself. It's actually giving off the electrons. It prevents the iron from being corroded, right, by getting sacrificed itself. So that's wrong. Okay, if the coating is damaged, water and oxygen do not corrode the iron. Yep, that's true. That's the beauty of galvanizing, because even if the coating is damaged, the more reactive metal will corrode itself to prevent iron from corroding. And see, zinc is a sacrificial metal and corrodes in preference to irons. That's true because it's more reactive than iron, therefore it'll tend to lose the electrons. We've studied this. So 2 and 3 is the right option. Which diagram represents the arrangement of outer shell electrons of a noble gas? A noble gas should have a complete octet or a complete doublet. If you check it out, B has 1, 2, 3, 4 electrons, so B is wrong. It's a group 4. 1, 2, 3, 4, 5, 6 outermost electrons. That's also wrong. 1, 2, 3, 4, 5, 6, 7. That's also wrong. This 2 is right. Now you guys might say, oh, it's not complete. These numbers, you can think about helium. They've confused you with helium here. Helium is also a noble gas and it has a duplet, right? So it has one shell and that's also complete. So A is the right option here. Which statements about the general properties of metals are correct? They are good conductors of heat and electricity. That's true. They have low melting points. Nope. They react with dilute acids to form salt and water. Nope. Why? Because they react with dilute acid. Let's say magnesium reacts with a dilute acid. They give you salt, not water. hydrogen, salt and hydrogen, right? It's a displacement reaction. They react with oxygen to form basic oxide. Yep, that's true. So 1 and 4 is the right option by far. Therefore, B is correct. Now, reactions of three metals and their oxides are shown. Okay, what is the order of reactivity for these metals from most reactive to least reactive? Check it out. One is actually reacting with HCl. So one metal 1 is reacting with HCl, which means it has a greater reactivity than hydrogen, right? Metal 2 is also reacting with HCl. It has a greater reactivity than hydrogen in the reactivity series. And metal 3, it's not reacting with HCl. Think about it. If metal 3 isn't reacting with HCl, it means it's somewhat like copper or maybe silver or gold, because they will have less reactivity than HCl. That's why they don't react. So 3 will obviously be the least reactive of these lot, right? So you realize that D and B तो वैसे गलत हो गए. The least reactive is 3. Now between M1 and M2, let's check it out. Heat metal oxide with carbon, and this one will react. If this is getting reacted with carbon, let's remember iron oxide, you would literally reduce it with carbon, right? Carbon monoxide or carbon. Why? Because carbon had a greater reactivity than iron, therefore it was reducing it. So think about it. If metal 1 literally reacts with carbon, you'll realize that carbon has a greater reactivity than that metal. Therefore, 2 is the most reactive, then after that 1, then after that 3. If you didn't get this, think about it like this. Remember your reactivity series? Please stop calling me a careless zebra. Instead, try learning how copper saves gold. So careless, zebra, careless. So after careless, zebra instead is iron. Try learning. So all the zinc, iron, they can all be reduced with carbon because it had a greater reactivity, right? Remember how we extracted these? So that'll make sense. So 2, then 1, then 3, therefore C is the right option. Three metal compounds JKL are heated using a Bunsen burner. The results are shown. Colorless gas produced which relights a glowing splint. That's obviously oxygen. It's not hydrogen, because hydrogen is a colorless gas which literally makes a pop sound with a lighted splint. Colorless gas being produced which turns lime water milky, so that's going to be carbon dioxide, and L is no reaction. So it says K. Which row identifies J, K and L? So J cannot be magnesium carbonate, because when magnesium carbonate you heat it, it thermally decomposes to form magnesium oxide and carbon dioxide, right? So that's K. K should be magnesium carbonate because that's giving carbon dioxide. So K is magnesium carbonate, therefore potassium, this is wrong, this is wrong, this is wrong, because K can only be magnesium carbonate right here. C is the right option. And think about it, J is potassium nitrate. Although this reaction is not in your course, but potassium nitrate, when it will be heated off, it decomposes to potassium nitrite and oxygen gas, right? So that gives you the oxygen. Yep. So potassium nitrate. And L is no reaction, so that's true right here. Potassium carbonate, they don't thermally decompose. They're very, very stable thermally. The diagram shows the uses and treatments and processes of muddy river water. Muddy river water, use 1. Obviously, muddy river water is not used for drinking, so A and B is wrong. It is either used for, it's used for watering crops. Yep. Then when you take muddy water and you convert it into a clear river water, right? So what do? You actually will filter it. So muddy water will have all that mud in it, and these are like solids, and that solid blocks will be filtered out into clear river water. Then how do you disinfect water? You disinfect water by adding chlorine to it to kill out all that microbes or bacteria in it. And what is the use of disinfected water? The use 2 is literally drinking, right? So watering crop is the use 1, drinking is use 2, process 1 is filtration, and the second process is chlorination. Therefore D is the right option. The equation for the manufacture of ammonia in the Haber process is shown. The reaction is exothermic, so forward is exo, backwards is endo. Which row describes the effect of stated change on the rate of the reaction and the yield of ammonia? Think about it. If you increase the temperature, obviously the rate of reaction will increase, but increase in temperature favors the endothermic bit, so more reactants will be from ammonia, decreases. D is wrong. Increase in pressure will increase the rate of reaction. That's true, but increase in pressure favors favors less number of moles of a gas, and here you have 2 moles and here you had 4 moles. So ammonia yield will increase, not decrease. Decrease in pressure decreases the rate of reaction, but if you decrease the pressure, the rate of reaction will decrease, and decrease in pressure favors exothermic bit, so the yield of ammonia will actually increase. Therefore B is the right option. If you check A out, decrease in pressure will not increase the rate of reaction, it decreases, because you realize less collisions over that stuff, less frequent. Yeah, fertilizers are used to provide 3 of the elements needed for plant growth. Potassium is needed, nitrogen is needed, and phosphorus needed. NPK, remember we studied NPK fertilizers: potassium, nitrogen, and phosphorus. Now they should have all of this. So which two compounds would give a fertilizer contain all the 3 elements? So this has nitrogen and this has no potassium or phosphorus. Nitrogen and phosphorus, no potassium. Potassium, nitrogen, but no phosphorus. Potassium, nitrogen, phosphorus. Yep, D is the right option. The flow chart shows part of the process for the manufacture of sulfuric acid. If you take dilute sulfuric acid, H plus and SO4 2 minus, you have the OH minus. So what will happen is dilute sulfuric acid will either give you, because the hydroxide, they're not give specified what electrode they're talking about. So it'll either give you the H2 gas or the O2 gas, right? So this gas can either be H2 or it can be O2. Now it says gas 1 and gas 3, and then making sulfuric acid. So for sulfuric acid, this gas 3 should be SO3. Remember, this gas 3 should be SO3. Why? Because this SO3 will then react with water to give you this concentrated sulfuric acid. And what will this gas 1 be? Gas 1 should be sulfur dioxide. Why should it be sulfur? Oh my god. Why should it be sulfur dioxide? Because this sulfur dioxide would react with what? Would react with oxygen to give sulfur trioxide, and then that would react with water to give you concentrated sulfuric acid. So sulfur dioxide plus O2. So gas 1 is sulfur dioxide, not trioxide, and then that'll react with O2, oxygen right here, to give you sulfur trioxide. B therefore is the right option. Which statement about sulfur dioxide is correct? So it says sulfur dioxide decolorizes acidified potassium manganate. Yes, it does. Why? Because it is a reducing agent, and reducing agent react with reducing agent ka test tha, it reacts with oxidizing agent. So potassium permanganate was purple and then it becomes colorless. So it does do that. So 1 is right. Therefore C and D are wrong. Now sulfur dioxide forms when acid reacts with carbonates. No, acid reacts with carbonates. Oh my god, that's so stupid. Sulfur dioxide forms when any acid take HCl and reacts with, like, let's say magnesium carbonate. Where is sulfur here that it's gonna form, right? So 2 is absolutely wrong. Where did they even get this option? Sulfur dioxide is used as a bleach. Yep, it is used as a bleach. We studied that property, right? So it has that bleach property to it. Sulfur dioxide is used to treat acidic soil. No, it's a non-metal oxide which is acidic itself. Acidic soil is treated with a base, right? It's a basic oxide. So 4 is wrong. 1 and 3 is the right option. What are the products when limestone is heated strongly? So limestone is calcium carbonate, which is used in your Taj Mahal. So it gives you calcium oxide plus carbon dioxide. So calcium oxide plus carbon dioxide. The structure is shown, name and which alcohol and which ester. Okay, so the ester's names, you realize that this is what? So if the carbon is directly attached to the O, you realize that carbon, and if there are all other carbons, that'll be from the alcohol bit. And the carbon which is double bonded to the oxygen, this carbon and the carbons before it, or the carbons attached to it, will come from the acid bit. Remember? So which acid is this? That's ethanoic acid. And which alcohol is this? That's methanol, only 1 carbon, right? So methanol and ethanoic acid are the reactants that were used, and the name of the ester will become, the alcohol will lose the OL bit and they'll get the YL, right? So it'll become methyl instead of methanol, right? And I gave you guys the reasons for that. And the ethanoic acid will become the ethanoate, right? Lose the Oic bit and become the O8. So methyl ethanoate, and the carboxylic acid is ethanoic acid, and the alcohol is methanol. C is the right option. Ethanol is made industrially by fermentation of glucose or by the catalytic addition of steam to ethene. Which statement describes an advantage of fermentation compared to catalytic addition? So what is the advantage of fermentation? Obviously, it uses a renewable resource, that is glucose. D is the right option. But if you check A, B, and C out, we can even eliminate this. Ethanol is the only product of fermentation? No, carbon dioxide is also formed. Fermentation uses a batch process, but catalytic addition is continuous. That's a disadvantage, dude. It means कि fermentation step by step होता है, right? So you take one batch, you do that. You take another batch, you do that. So it's time consuming. Catalytic addition continuous. Do it, do it, do it, do it. You bring in the stuff, raw material डालते जाए, होता जाए. So it's a continuous process, right? Fermentation uses a higher temperature than catalytic addition. That should be a disadvantage too. So C is also wrong. And although that isn't the case, right? Yeah, it uses 20 to 35 degrees Celsius. Some properties of colorless liquid are listed. Okay, it boils at 65 degrees Celsius, so obviously it should be like, oh, I can even say it's hexane directly. But let's check it out. When added to water, it forms two layers which do not mix. Now you realize that even in your A levels you'll study this. Okay, water and organic solvents, they don't mix, right? So you realize that hexane and water won't mix, right? So hexane and water won't mix. So the option is ethanol mixes with water. They're saying two layers which do not mix. Now ethanol and ethanoic acid will mix. They'll dissolve in water, right? Ethanoic acid is an acid. They will mix. They're soluble in water. Ethanol is also soluble in water, right? Take some alcohol, pour it in water, they will mix. It's all you. That's why when you go to raves and parties, you can't see the difference. The police can't see the difference between water and alcohol because there's no layer that's being formed between ethanol and water. And later on, you'll study this, why this happens is basically due to hydrogen bonding. But for now, just realize like vinegar, you can't tell the difference between water and vinegar if they were forming like two immiscible layers which were not actually mixing with each other. Then you would have done that. But that's not what happens in our real life. So the only two options you have is hexane and hexene. And then it says it has no effect on bromine water. So if it has no effect on bromine water, you'll realize it's obviously gonna be hexane, not hexene, because hexene is an alkene and it'll decolorize that bromine water. A molecule of compound P contains 2 carbon atoms and 4 hydrogen atoms. So 2 carbons and 4 hydrogens. So 2 will be here, 2 will be here. There will be a double bond between these two then. It says what is the name of the compound is going to be ethene, so A is wrong, and it has the MR of, so 12 plus 12, that is 2 carbons and 4 hydrogens, so plus 4. So 24 plus 4, that's 24 plus 4, that's 28, right? So ethene, the MR is 28, therefore B is also wrong, and reacts with aqueous bromine. Yep, it does. The reaction of ethanol with acidified potassium manganate is shown. Which type of reaction is taking place? So you had alcohol, it's going to carboxylic acid, you realize oxidation ho rahi hai, right? And KMNO4 is an oxidizing agent, so it reduces itself to oxidize alcohol, therefore D is the right option. Which polymer is a synthetic polyamide? Polyamides, we studied it's either nylon and it's either protein. Now, which one is a synthetic? Man-made. Man-made is nylon. Therefore, A is the right option. And we're done with this beautiful past paper. Obliterated it. Take care, guys. See you guys in the next bit. Comment down below which past paper we should do next. Okay? All right, guys. Tell me you guys. Any questions?